Welcome to our Scaffolding 101 explainer, where we're going to treat this absolute engineering marvel like a true masterclass, literally building it step by step from the dirt up. If you're in the industry, you already know that erecting a scaffold isn't just throwing some metal tubes together, right? It's a highly regulated, mathematically precise operation where gravity is constantly testing your work. Today, we're taking Jazzvere's comprehensive guidelines and breaking them down so you know exactly how to safely assemble these structures. Let's look at our syllabus for today. We're breaking this into 3 crucial phases. 1, the base, 2, the main structures, and 3, the working platform. So let's jump right into phase 1, the base, building the foundation. Think about it. Every safe structure entirely depends on what sits underneath it. You could build the most perfect platform up in the sky, but if your foundation is compromised, the whole thing comes down. Before a single pipe is locked into place, the official guidelines require a thorough terrain assessment. Are we on a slope? Are we near an excavation? The ground, whether it's soil, sand, gravel, concrete, steel, or a slab surface, dictates your entire foundation strategy. For instance, the rules clearly mandate that a scaffold must stay a minimum of 1.0 meters away from any excavation and 300 millimeters away on sloped ground.
So how do we actually distribute all that weight depending on the surface? Well, if you're building on weak ground, you definitely don't just plant your steel and hope for the best. You have to lay down a sole board, and it's got to be exactly 450 by 225 by 38 millimeters. Meanwhile, you're using a 150 by 150 millimeter base plate on every single standard to really support and spread out those individual weights.
If you're building this out, here's a vocabulary term you absolutely need to know: the kicker lift. Now, this is an optional feature, but if you do use it, it has to sit at a minimum of 150 millimeters off the ground, and it absolutely must be perfectly squared. But what if you skip it? The rules are incredibly strict here. If the kicker lift is omitted, you're required to install a plan brace instead to lock in that foundational square shape. Building up from that base, we hit a really crucial number, 2.7 meters. That right there is the absolute maximum height allowed for your first lift. And it isn't just a random number they pulled out of thin air. It is specifically designed to accommodate safe access and egress for the crew navigating the lowest level of the site.
All right, so with our base completely locked in, tightly secured with the right couplers, and fully compliant, let's transition to step 2 and build out our vertical and horizontal strength.
Welcome to phase 2, the main structures. This is where we assemble the skeleton. This is where we actually piece together the skeleton of the scaffold. We use plumb standards. They have to be perfectly straight, zero damage, paired with properly leveled ledgers. Which brings us to another super important part of our skeleton, the transom. These are your horizontal framing members spanning across the ledgers, and the engineering gets really specific here. Structural transoms have to be fixed using right-angle couplers either into the standard or the ledgers, precisely at a 300 millimeter node point. Intermediate transoms, on the other hand, just use single couplers.
So the big takeaway here is this measurement, 1.2 meters. That is the maximum allowable distance between those intermediate transoms. Why? Because these transoms are what actually support your platform boards. If you space them out any further than 1.2 meters, you're risking those boards sagging or straight up breaking under the weight of the workers and their gear. It's a precise measurement meant to completely guarantee structural integrity.
Now, bracing the skeleton comes with its own set of complex rules. You definitely can't just slap a brace anywhere and call it a day. Notice the strict intervals. Ledger bracing goes at both ends and on alternate pairs of standards. Sway bracing, that's positioned at a maximum of every 6 bays. And pay attention to the hardware. Swivel couplers are always used when fixing to the plumb standards, while double couplers are reserved for fixing to ledgers or structural transoms. It is a highly methodical system designed to withstand wind and shifting loads.
Moving right along, our skeleton is fully braced, our interval lift heights are set every 2 meters, bay distances are perfectly spaced according to load classes 1 to 4, and the whole setup is completely free of damage. So we move to the final step, introducing the human element. Phase 3, the working platform, securing our altitude. This phase is all about properly securing those platform boards, ensuring there's zero damage and absolutely no dangerously large gaps where the actual high-altitude work happens. But before I just give you the compliance measurements, ask yourself, as an inspector, how much empty space is actually permitted along the edge of that platform? We know we have a toe board at the bottom to stop tools from getting kicked off, and a top guard rail to stop bodies from falling. But what about that space in between?
Well, the answer is 470 millimeters. That's exactly where your mid-rail goes. By ensuring the gap is a maximum of 470 millimeters between the toe board and the top rail, you're making absolutely certain there simply isn't enough room for a worker or heavy materials to accidentally slip right through the middle of the guard system. Let's add one more term to your scaffolding vocabulary, the puncheon. This is a specialized support component fixed on both the top and mid-railing using double couplers. Its entire job is specifically to guarantee that those toe boards remain rigorously secured in place. It adds a crucial extra layer of rigidity right at the perimeter.
Keeping up with our precise metrics here, 950 millimeters. That is the minimum mandated height for your top guardrail, measured straight up from the platform's surface. It is literally the critical barrier standing between the workforce and a catastrophic fall. Oh, and those platform boards they're standing on? The overhang to the last transom support has to be tightly controlled too, a minimum of 50 millimeters and a maximum of 150 millimeters.
Okay, so how do we actually get up onto this platform? When setting up access, your internal access ladders, which, by the way, need openings of 450 by 600 millimeters, or your external ladders, they must be perfectly angled at exactly 75 degrees. You can't just lean them against the metal, they have to be secured properly from the top all the way down to the bottom stile.
And here is a massive safety rule. Why do you have to extend that ladder exactly 1.0 meter past the platform landing? Simple. It ensures a safe, continuous handhold when a worker is stepping off the ladder and transitioning onto the platform boards. That extra meter gives them something incredibly solid to hold onto right when their center of gravity is shifting.
Finally, to cap off this working platform phase, your landings have to be absolutely clear. Zero obstructions. If you have an access gate, use it. If you don't, the rules mandate a self-closing drop bar. And if you're dealing with external ladders reaching their maximum heights, cages are strictly required for that extra layer of safety. As you can see, every single access point is heavily regulated.
So we'll leave you with this thought to wrap up our masterclass. If just one of these precise measurements fails, does the entire structure fail? Think about it. From those 450 millimeter sole boards spreading out the load down in the dirt, all the way up to those 950 millimeter guardrails high in the sky, every single millimeter and coupler we've talked about today has to work together as a unified system to defeat gravity. It's a great reminder that in scaffolding, safety isn't some approximation. It is an exact, measurable science. Thanks for hanging out with us for this explainer, and we'll catch you next time.